Yo, what's up? It's your boy, Mr. AC. And what I got for you guys today is going over primarily, and we are on year number. So let's go ahead and get started. Let us get rolling to the 2007B question. Now, you'll notice the 2007B question has a lot of things that are very important, and it's slightly different than the other problems that we've done because it actually tells us that this graph consists of two semicircles and two line segments. That means we can actually find the area under the curve if it asks for absolute min or max. Part D is asking for absolute min or max. So the previous video, we had to do these crazy sketching. These ones are a little bit more manageable. And then don't forget, they gave you an initial condition right here that f of 1 is 3. So let's go ahead and start part A. Find all the x values at which f, so we need to find f prime because it's asking for when it has a relative maximum. Let me draw a graph. Maximum should go from positive 0 to negative. So I'm gonna look on this graph. When does it have a slope of 0? Here, 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 and here. Obviously, we're excluding the endpoints because they told us that. And what's happening? Well, anything up here is positive. Anything down here is negative. So that tells us then, because this is the graph of f prime and we're thinking about f prime, this is positive to negative, negative to positive, positive to negative. Well, where do you need to have a relative max? Well, when we go from positive to negative is at -3 and at 4. So I'm going to go ahead and write this right here for part A. So finally, I can conclude f has a relative maximum at x equals -3, x equals 4, because f prime changes from positive to negative. And that'll complete part A. Let's go ahead and go to part B, y'all. Part B. Okay, part B, find all the values of x at which f has a point of inflection. So it's talking about f double prime. Well, what are we given? We're given f prime. So to find the points of inflection, we need to know when f double prime changes signs. I'm obviously going through this a little bit faster now that we've hopefully through the last maybe 7 problems, you got an idea. So I got to take the derivative of this. So if I take the derivative of this graph, we have a slope of 0 here. We have a slope of 0 here. This is undefined right here. This is also undefined, but that's okay. We're going to take that into account. So we have potentially 4 spots to examine. Well, if I take the derivative here, we're taking the derivative. This is positive to negative. Here it's negative to positive. Here it's positive to negative. I'm going to skip this because this goes from positive to positive. So where do I have points of inflection? Well, I should have a point of inflection at -4. I should have one at -1, and I should have that one at 2. So this is what I'm going to go ahead and write now for my justification. F has points of inflection at x equals -4, -1, and 2 because f double prime changes signs at those values. And that would be our perfect justification for part B. So hopefully it's all making sense. Let us go ahead and go to part C. Part C, find all the intervals on the graph of f on which the graph of f is concave up and also has positive slope. So essentially, if we're going to have positive slope, that's saying that we need f prime to be positive, and to be concave up, we need it to be also positive. So to have positive slope and be concave up, both derivatives need to be positive. Well, we're given f prime already. Anything up here, as we talked about, is positive for f prime. Anything down here is negative. So that tells us right away, in order to satisfy this condition, positive slope, we're going to ignore everything on the bottom, because down here has negative slope. So we're not obviously going to look at that. Now let's go ahead and find out where f double prime is positive. Well, we kind of did this, and it's kind of a combination of A and B, because from here to here it's positive slope. From here to here it's positive slope. This is obviously negative slope, right? So we can conclude right here. It says find the intervals. They should be intervals. So I'm going to go ahead right here and then go ahead and write down this right here. Okay, So I'm just going to write f is concave up and has positive slope on the intervals -5 to -4 and 1, 2 because f prime is positive and f double prime is positive, right? They're both positive. They completed the requirement and we're good to go. Let us go ahead and move on to part D, y'all. Part D, find the absolute minimum value of f of x on the closed interval. Now I'm going to write it over here in this corner. That means we need to find the smallest y value on this function. So -5 and 5. We need to check our endpoints. And when we check our endpoints, we need to know what the y value is of the original function. And we're given f prime. So that tells me already that I'm probably going to have to use the antiderivative to get back to our original function. Well, first things first, it's asking for absolute min. So we do need to check the endpoints, but we also need to check where it has relative minimums because we don't know if the minimums dip farther than the endpoints. So if I look on my graph, this was f prime. Remember, this went from positive to negative. This went from negative to positive, and this is from positive to negative. Because I'm asking about absolute minimum values, I only care about my relative minimums, which minimums, if I draw it, right, this is f. The slope should go from negative to positive. Well, this is f prime. So 1 is a candidate that we can test as well. And there's no other ones that we can test. So let's go ahead and do this together. How do we do this? Well, we need to take the antiderivative. So I'm going to put an integral symbol here for now, right? This is going to be, well, -5. So I'm going to put the -5 up here. And this is f prime of x dx, right? We got this right here. Well, what is the lower bound? That's the issue. Well, good news is they gave it to us right here, right? This is the initial condition. So if I want to put the 1 on the bottom, I'm going to have to put the 3 in the front. So it'll be 3 plus. Now, this needs to go from most negative to most positive. So I'm going to write it like this. I need to flip the symbols because it needs to go from most positive to most negative. When I do, that just means the area becomes negative there. So then I put a minus sign outside. And then I'm going to do the exact same thing here. So I'm going to do 1 up here, f prime of x dx. And then we put the initial condition is 1. So this one goes down here. 3 plus, and then I'm going to do the same thing over here. I'm going to get 5, and then down here is going to be 1, 3 plus f prime of x dx. And then before I do anything else, the area from 1 to 1 is 0, right? There's no area from 1 to 1 because this is technically not an interval. So we know this is already 3. And then over here, we need to find the area from 1 to 5. And then we need to find this area up here. I guess I'll do the bottom one first because I already can tell right here, if you kind of take a moment to look here, from 1 to 5, I need to find this area right here. This is just a triangle. And then I need to subtract it by this area down here, which is also a triangle. So this is going to be 1, 2, 3. 3 times 2 is 6. Divided by 2 is 3. So we get 3 plus 3. This is from the area that we just took. This is from the initial condition. And then this is going to be 1 times 1 divided by 2. So minus 1/2. The 3 plus 3 is 6. 6 minus 1/2. This is 5.5 right here. So far we've got these completed. And then we just need to do this one. This is from -5 to 1. And this one's going to be a little bit tougher because if you notice, these ones are the ones that involve the semicircles. The area of a circle is pi r squared. Because it is a semicircle, I need to divide it by 2. So this right here, the radius of this circle is 1. 1 squared is 1. So this is going to be pi over 2. Right here, that is from this area in here. And then we have this other semicircle. This semicircle has an area, not an area, a radius of 2. So this is going to be pi r squared. This is 2 squared is 4. 4 divided by 2 is 2. So we get minus 2 pi like this. Boom, and we get this function right here. Now I'm going to go ahead and write this as 3 minus, well, I can basically get common like terms. I can divide this by 2 and then multiply this by 2 so that this inside here becomes pi over 2 minus 4 pi over 2. And then last but not least, I'm going to get 3 minus, and then we get, this is negative 3 pi over 2. And then this becomes positive, right? They're going to become addition. So we get this right here. So I'm going to stop for a moment. 3 plus 3 pi over 2. I want you to notice, we're talking about absolute minimum value. You already know, because you saw that this turned positive, this is bigger than 3 and this is bigger than 3. So I can now conclude that my absolute, so I'm going to write the absolute minimum value of f of x over the closed interval is 3. And I am done. And the work that I've shown is my justification. It's one of the only problems on the AP exam where this work shown is your justification. And obviously I would organize it in this table manner. Obviously maybe a little bit better. Obviously I just have to write big for the video, but we're gonna write is -3 on this closed interval. So hopefully that makes sense, y'all. We're gonna go ahead and move on to 2009.